Moving right ahead, problem 5. So, this is the one where you've got something set up like this, where you've got A creating, waves that reflect off the barrier to get to B, or that go straight to B. And so we want to know how you get constructive or destructive interference at B. And the trick here is that when you have this reflection thing, this reflecting barrier, and it's reflecting waves upright, it acts as though you can imagine it as though there's a mirror image of this whole thing over here. So there's another source at this point A prime, which is an equal distance from this sort of imaginary line where the barrier is. I guess the way I might explain it is, here is A making circular waves, okay, and then here is where it hits, and you get the reflected waves that look like, I'll do the reflected waves in lavender, and the reflected waves look like that. But really the reflected waves are just semicircular bits of what you might imagine as being full circular waves from, I'll just leave lavender, from a point A prime, okay? And so in here, and then maybe like that. And so you can see then how the reflections from A, and for example, here's another even bigger, further along one, and that's really a reflection from this wave, but it looks as though it's a wave from A. And so basically, if you just solve the problem as though, what did I say in the problem? There's 8 centimeters here, and then it's 30 across. So solve the problem as though you have 16 centimeters and 30 centimeters. Okay, then you can say, S1 is 30 centimeters. So that's the distance from A to B. And then S2 is, whatever, square root of 16 squared plus 30 squared is, I have no idea what, but, yeah, I don't know what it is, but you get the idea, right? Okay. And then for part A, you want the longest wavelength that will give you constructive interference. So you just want S2 minus S1 equals m lambda. Well, what value of m gives you the longest wavelength? And pretty clearly that's 1. You can't have 0. It can't be 0 lambda because these two aren't equal. Okay, so that doesn't work. And then, so that's for part A. And then for part B, you want S2 minus S1 equals, and then remember it's n minus 1/2 times lambda. And so the maximum that can be is, or the maximum wavelength comes when you have 1/2 lambda. So that's really, the whole point of the problem was to show you this reflection thing. Get you to think about that. So anyway, that's that.